Hello. It is August 10th. It's a Sunday. And recording a video after a while. So the title, what was the title? I'm forgetting. But it was I'm Alive. And part of that was because it was kind of a double meaning. Like one is I feel alive. I feel very energetic. But also I haven't made a video in a while. So it's kind of I'm alive as in I'm making the video. Yeah, I thought it was more interesting in my mind. So, yikes. Okay, but let me for today. I just want to be doing a quick lead code because I haven't done this in a while. Actually, wait, I was using lead code, not lead code. Let's see. I thought I assigned it. Have I not signed it? It was definitely tracking. Maybe GitHub? Yeah, I think I was logged in. Great. Okay, what should I do? Let's do graphs. Graphs are always fun. Lead code 150. Let's do surrounding regions. Great. Okay. You are given a 2D matrix board containing X or 0 characters. If a continuous 4-directionally connected group of zeros is surrounded by X's, it is considered to be surrounded. Change all surrounding regions of zeros to X's and do so in place by modifying the input board. Okay. I'm gonna have to read that again. You are given a 2D matrix board containing X and 0 characters. If a continuous 4-directionally connected group of zeros, 4-directionally, okay, I think that means a square, it is considered to be surrounded. Change all surrounded regions of zeros and X's to zeros to X's and do so in place by modifying the input board. Note that regions that are on the border are not considered surrounded regions. Great. Cool. So the way I'm thinking about it is the brute force approach to go about this would be you look at the entire board and then so I mean you can iterate through each you can kind of there will be a lot of duplicate work, but you start from the top left and then see if you're at a 0. If you're at a 0, then you check if you have 4, and if you have 4, and then you have then you kind of go through the X's around. But this one's not surrounded by X's. That's interesting. Surrounded by X's. So I guess surrounded here just means these X's. So it doesn't have to be the diagonal X is not counted, it seems. I guess. It's not very clear what this means. I want to make sure I understand the question correctly. Let me ask ChatGPT just quickly. In the surrounded regions lead code question, can you explain it once to me? Sure, sorry, capturing. Remember, zeros in all 4 directions, up, down, left, right. Make sure not to tell me the answer, but explain the question well. I see. So 4 directionally. Oh, I see. So it doesn't just have to be a square. It could be any. What does it mean to be completely surrounded? Every path from that 0 to the edge of the board is blocked by X. As far as you move up, down, left, or right, you'll always run into X's before reaching the outer border. There's no route through connected zeros that leads to the border. Got it. So, okay. Yeah, I'm at first not sure how to go about this. Like, I don't have the solution in my mind right now. But so let me try a couple approaches. So one approach would be you start from the outer end of this square and you start looking at the border. And then you look at the border and then you start moving inwards. So if there's an X on the border, you keep moving. And if you see an O, you can kind of start, you can maintain that as a, and so yeah, so brute force would be you just keep moving up until you reach a 0. And then you move up, down, left, right in all directions. If you encounter zeros, you're kind of, you just keep moving. And if you hit X's and not the border, then you know that that can be, that entire region can be removed. And if not, then you delete it. So you can just keep track of the currently active zeros, like the indices of the cells that are kind of in question. And I mean, so essentially what the task is that we need to move through all these zeros. And if it's connected to a border, then leave it alone. So we need to mark somewhere that it's left alone. If not, then we need to yeah, that's the tricky part. So let's say we're at a 0. We move right. We'll have to move in all directions. And at each step again, we'll have to move in all directions. I mean, so basically, the reverse of that would be you just move through, and any zeros that can be connected from the border, you mark them as zeros. Everything else can essentially be is surrounded by X's. So that would be like the classic way to go about this. The more complicated way would be like you kind of add a 0 and then you keep moving in all directions. When you hit an X, you stop. Um, and if you hit and you have to track extra state, and it would kind of be a hassle. So, okay, that makes sense. And so how would I do this to keep moving through zeros, traversing zeros? So if I find a 0 on the edge, I would move in all directions. And in each of these directions, at each point, I would just keep moving up until it's a 0, and I would add that to my set of kind of saved indices, and everything else just becomes an X. Yeah. So, how exactly would this moving in each direction look like? I mean, at each step, you can just move in all directions. That's one way for sure. Yeah. And so, when moving in all directions, do I need to move in all directions? Give me an example where it's not surrounded. I'm not sure. I mean, I'm thinking about a case where this X right here, is 0. I mean, would that render this whole square now? Or it's unclear. In this example, if if y 0, 1, 2, 3, 0, 1, 2, if y 3 x 2 is 0, would there be no connected no so that's wrong, right? Just let me edit when there's y 3x2. Okay. So yeah, then you do just kind of move through. So let me start writing in code because I think it'll become clearer. But actually, let me try planning ahead. It's not a bad idea. So how would this work? Yeah, at each step, I'd basically, if I found a 0, I would just move in all directions and keep moving. Yeah. And if I found a 0, I would then do the same thing. I'm thinking now I could avoid potentially moving. No, I have to move all directions. Yeah. Yeah. Okay, cool. So I don't think there's any recursion here. I can't break it down into at least a conception that seems recursive. I mean, let's see. All right, okay. Let me try thinking about it up front. Is there any recursion? So there'll be. So what are the components here? There's going to be a for loop that goes through the borders and runs our traverse function. In each step of the for loop, we're basically continuing to move. We're basically moving in all directions. I mean, so we basically do that with a queue. Or this is where we could recurse, right? I mean, it's basically a depth first search or a BFS. And yeah, it might make sense to use a recursive function here. Yeah. We call a recurse function traverse. And so yeah, we're now calling traverse, and that's going in and traversing. And then at the end, so let's see how our traverse function would work. And so in our traverse function, we'd have to store a set of all the visited kind of regions. Yeah. And that's protected, basically. And in traverse, we'd be we would take in an x and y coord, and we'd move in all directions. Call traverse for all directions. And at each step, if 0, if it's a 0, and then we'll for all directions. Okay, that's great. If not 0, we can stop. Also check for out of bounds. Also make sure not to retraverse visited. At the end, we run a for loop again and mark all unvisited zeros, unvisited zeros as x's. Great. Okay. Let's try to now write this code as fast as possible. Okay, so at the start, no, that's wrong. We actually don't want this. So you want to go through all directions actually. So calls. So then for each row border, So at the end of this, what we would hope is that if row column I'm falling. Yeah, I'm feeling I felt a little bit tired right now. Okay, so we had an out of bounds check. If it's invisited, I love that. Call in okay. And then in the middle, we would actually call it for all directions now. So it's a 0. And so we want to add this to the visited. And then moves. Great. And then at the end, if if it's a 0 and if it's not in visited, basically is set it to be equal to x. Great. Okay. I think it's an O, not a 0. That's better. I see. I just moved everything. Why didn't it? Oh, I see. It was supposed to. Why didn't it call traverse on this? To use my funky IJ. Okay. How's this? I gotta click answer. One loop over all cells. Over all cells. Interesting. But the board is empty. Cool. So 36 minutes. Not too bad, honestly. It felt like it had been longer. That's, I think, a good, given the time I took to think about it and think it through, I think that's good. And I'm working on celebrating when I do something well. So let me try and feel good. That was good. Awesome. Back soon.